All right. Good afternoon, everyone. Good afternoon to you, sir. This is my final project for the first semester 2021-2022 for the subject data communication and networking 2 or ITS 302. So the topic that I've chosen is all about uh, TCIP or transmission control protocol or transfer control protocol, I'm sorry, or the or sometimes called the TCP IP. IP stands for internet protocol and the OSI model. So this is the topic that I've chosen to elaborate with you in this afternoon. So here are the visual representation of our topic this afternoon. So um, before we jump to the topic about TCP/IP or what is TCP/IP and what is OSI model, first we need to understand what is internet. Who made the internet? First of all, so internet was conceived in 1962 by J.C.R. Licklider of MIT as a galactic network that would connect a group of computers so they may access data and programs regardless of where a single computer was located. And through the experimentation, after MIT researcher Leonard Kleinrock and Lawrence G. Roberts expanded upon Licklider's idea and theorized the feasibility of such an innovation, meaning to say that they found out that this invention or idea is very, very useful in sometimes in the future. They managed to successfully link two computers from Massachusetts to California via a low-speed dial-up telephone line in 1965. And in the development phase, by 1968, the Defense Advanced Research Project Agency, or DARPA, guided the technology and its development under the project name ARPANET and honed the border aspects of the project, such as its structural and technical parameters, architectural design, and key components like interface message processor or IMP. So the next would be the inception. After the very first host computer was connected to the first node at UCLA in 1969, the Stanford Research Institute connected the host to host messaging, and that is the start of the network of the computer. Following this, with the addition of two nodes that dealt with the application visualization project for host computers were connected to the ARPANET. So what else? So as more and more computers were added to the network, function and utilization was the focus for improvements. Software was subsequently devised and the Network Control Protocol, or NCP, was implemented, thus leading to the need for more applications. In 1972, the budding network saw its culmination in the construction of the ultimate coordination tool, the electronic mail. So the protocol means the uses of protocol. When we study about later on in this topic, we will dive into what they call protocol later on, so we will understand what protocol is. Soon the ultimate goal of ARPANET turned to incorporation other separate networks through the foundational idea of networking architecture where they may be independently designed for a unique interface. This would be referred to as interneting. And throughout the late 70s and early 80s, there will be an extensive development of LANs or local area networks personal computers or PCs and workstations that would not lead to more would not just lead to more networks but more modification of the initial model. And by the mid 90s, the internet was a respected and well supported technology that was embraced not only by those in the research communities but the mainstream masses for personal communicative uses too. So today, the internet is one of the most effective and efficient way to communicate. Whether it is through Facebook, MySpace, Yahoo, or another website, the internet gives us the opportunity to connect with all kinds of different people and with news and information from all over the world. So, with that in mind, we might ask, how does the internet work? So let's find out. So basically, it works using a packet routing network that follows Internet Protocol, or the IP, as stated earlier, and Transport Control Protocol, TCP. The TCP and IP work together to ensure that data transmission across the internet is consistent and reliable no matter which device you're using or where you are using it. Okay? So, what is Transport Control Protocol, or IP? The transmission, or sometimes called Transmission Control Protocol, is a connection-oriented communication protocol that facilitates the exchange of messages between competing devices in a network. So, it is the most common protocol in networks that use the Internet Protocol, IP. Together, they are sometimes referred to as TCP/IP. So the Open System Interconnection, or the OSI, on the other hand, is a conceptual model created by the International Organization for Standardization, which enables diverse communication systems to communicate using standard protocol. So in plain English, the OSI provides standard for different computer systems to be able to communicate with each other. So in other words, a protocol is like a law that is observed by all, or the rules, or the step-by-step rules. So the OSI model can be seen as a universal language for computer networking. It's based on the concept of splitting up communication system into 7 abstract layers, which we will talk about later on, each one stuck upon the last. So you might ask, what is the difference between TCP, IP, and the OSI model? So here it is. The Open System for Interconnection, OSI model, is a conceptual model created. Okay. So we have been mistaken in putting up this file. I'm very sorry. Okay. Anyway, let's just move on. So to give you the idea, the difference between the two is that their function, I guess, because the OSI model is just setting up the standard for how computers communicate, and the TCP/IP controls the rest of the system. We will know about that later on as we move, so stick around. So what is the uses of TCP/IP, or Transmission Control Protocol, or sometimes referred to as Internet Protocol? So TCP/IP specifies how data is exchanged over the internet by providing end-to-end communications that identify how it should be broken into packets, addressed, transmitted, routed, and received at the destination. So TCP/IP requires little central management and is designed to make networks reliable with the ability to recover automatically from a failure of any device on the network. So the main reason is that to fix the communication between computers easily without any hassle. So IP defines how to address and route each packet to make sure it reaches the right destination. Each gateway computer on the network checks this IP address to determine where to forward the message. So we will understand that later on, how this thing works, because we will discuss about the 7 layers of the OSI model. So a subnet mask, on the other hand, when we talk about this TCP/IP, it is inevitable that we will come across the word or the term subnet mask, which tells a computer or other network device what portion of the IP address is used to represent the network and what part is used to represent host or other computer on the network. So let's move on. So common TCP/IP protocols includes the following: Hypertext Transfer Protocol, or HTTP, which we usually see in our browser, handles the communication between a web server and a web browser. So HTTP handles secure communication between a web server and a web browser. Yes. So File Transfer Protocol, on the other hand, handles transmission files between computers. So what are the other use of TCP/IP? Well, TCP/IP uses the client-server model of communication, in which a user or machine, a client, is provided a service like sending a web page by another computer or a server in the network. So collectively, this TCP/IP suite of protocol is classified as stateless, which means each client request is considered new because it is unrelated to previous requests. In short, it is just one way around. And the TCP/IP model differs slightly from the 7-layer Open System Interconnection, or the OSI model, networking model designed after it. The OSI reference model defines how application can communicate over a network. So last, the importance of TCP/IP. Therefore, the TCP/IP is non-proprietary and, as a result, is not controlled by any single company. Therefore, the IP suite can be modified easily. It is compatible with all operating system or OSs, so it can communicate with any other system. The IP suite is also compatible with all types of computer hardware and a network. What else? TCP/IP is highly scalable, and as a routable protocol can be determined the most efficient path through the network. It is widely used in current internet architecture. So here we are. We already talked about what is TCP/IP, or Transmission Control Protocol, and the Internet Protocol. Now we will talk about the OSI model, because TCP/IP and OSI model is not very different from each other. They have similarities they both play a major role in the internet world. Okay, so let's dive into it. So OSI model explained. So the OSI model is a conceptual framework that is used to describe how a network functions. In plain English, the OSI model helps standardize the way computer systems send information to each other. So learning networking is a bit like learning a language. There's a lot of standard and then some exceptions, but the more you study it, the more you will understand later on. So at first, it might seem very difficult, but trust the process, okay? So common networking terms that we should study before we will dive into the 7 layers of the transmission or the network, how computers communicate to one another. So here are some common networking terms. Nodes. So what is nodes? A node is a physical electronic device hooked up to a network, for example, a computer, printer, router, and so on. If set up properly, a node is capable of sending and or receiving information over a network. So nodes may be set up adjacent to one another, where a node A can connect directly to node B, or there may be an intermediate node like a switch or router set up between node A and node B. So typically routers connect networks to the internet, and switches operate within a network to facilitate intra-network communication. So here are the visual representation of the nodes. It's the arrow, the line that has the arrow, it represents the message that is passed from system A to system B. The message, it's like a message that has been passed. So links, what are links? Link connect nodes on a network. Links can be wired like internet or cable free like Wi-Fi. Links can be either be point to point, where node A is connected to node B, or multi-point, where node A is connected to node B and C. So when we're talking about information being transmitted, this may also be described as one-to-one versus a one-to-many relationship. So we will talk about that later on. So we must first get familiarized on these internet or networking terms to understand more easily, or to understand more the OSI model. So protocol. So what is protocol? A protocol is mutually agreed upon set of rules that allows two nodes on a network to exchange data. In other words, nodes are, for example, computers, right, that can send and receive information. So a protocol defines the rules governing the syntax, or what can be communicated, systematics, or how it can be communicated, or synchronization, when and at what speed it can be communicated, of the communications procedure. So protocols can be implemented on hardware, software, or combination of both. Protocols can be created by anyone, but the most widely adopted protocols are based on standards, or the ASCII. That's what they said. So both wired and cable-free links can have protocols, so both of them. Okay, for the network. What is a network? Here are the visualization of a network. So let's see what is a network. So network is a general term for a group of computers, printers, or any other device that wants to share data. Okay, so network types include LAN, local area network, or HAN, CAN, MAN, or metropolitan area network, or wide area network, or WAN, BAN, or private. Okay, private network, or VPN. So think I'm just randomly rhyming things with the word can. I can say am. These are all real network types. Okay, they don't just accidentally rhyme with each other. That's what their name is. So net topology, or in other terms, it is called network topologies. So here are the 7 examples of how a computer is connected to one another. So that's what we call topology, or the ways how computers are connected to each other's network. So topology describes how nodes and links fit together in a network configuration, often depicted in the diagram. And here are some common network topology types. Yeah. So what is OSI model then? Okay. So OSI model consists of 7 layers of networking. The layer is a way of categorizing and grouping functionality and behavior on a network. We will understand that more as we dive deeper. So in the OSI model, layers are organized for the most tangible and most physical to less tangible and less physical, but closer to the end user. We will understand that later on. So each layer abstracts lower level functionality away until by the time you get to the highest layer, all the details and inner workings of all the other layers are hidden from the end user. We will understand about that later on. So, number one layer in the OSI model is the physical layer. As we can see from the picture, it consists of all the hardware that a computer needs to function. Okay. So what is physical layer? Everything from physical network device, cabling, to how the cables hook up to the device, plus if we don't need cables, what the signal type and transmission method are, for example, wireless or broadband. So layer 1, or the physical layer, contains the infrastructure that makes communication network possible. So the best example for a physical layer is that of a server. Okay, even your computer can be hosted as a server. So it defines electrical, mechanical, procedural, functional specification for activating, maintaining, and deactivating physical links between network devices. So, in other words, physical layer consists all of the necessary hardware device such as your computer, your screen, your cable, your antenna, your Wi-Fi, everything that is physical that contributes, or the physical device or electronic device that contributes to the network in a computer. That's what we call the physical layer. So your phone, your laptop can be labeled as physical layer. So in the physical layer, there are nodes, there are device interface mechanics. Right? How and where does a cable connect to? Nodes, we already talked about what nodes is, right? And the functional and procedural logic, that is the protocol. We have already, yes, cabling protocol and specification, cable type, on how you will connect the two computers or the multiple computers together, signal type, and signal transmission method, maybe wired or cable free. It's either way. Okay, so that's what we have in the first layer, the physical layer. So before we move on, there's a quick info. So the data unit in layer 1 is the bit. Okay, is the bit. A bit, the smallest unit of transmittable digital information. Bits are binary, so either 0 or 1 bytes consisting of 8 bytes are used to represent signal characters. When you study about TCP/IP and OSI model, you must get used to. You must first understand the smallest unit of transmittable digital information, that is bits. It's either 1 or 0, and byte consists of 8 bits. That can be either 1 and 0 only. Therefore, bits are sent to and from a hardware device in accordance with the supported data rate. Okay. So nodes, we already know, nodes can be send and receive bits. That is the physical or the electronic device that can send and receive information. So move on to layer 2, data link layer. Okay, so layer 2 is the data link layer. It defines how data is formatted for transmission, how much data can flow between nodes, for how long, and what to do when errors are detected in its flow. So in other words, the data link layer acts like the administrator of a network, which controls the flow of information that flows around the network. And there are two distinct sublayers within layer 2. What are those? The media access control, or MAC. When you have phone, we are very really familiar with the MAC address. So the MAC sublayer handles the assignment of a hardware identification number called MAC address that uniquely identifies each device on the network. So a lot of people are confused about the MAC address and the IP address. Well, the MAC address cannot change. All right, every device has its own unique MAC address. On the other hand, the IP address is the one that can be changed. So the difference are, one of the difference, MAC address cannot be changed. It is temporary. It is permanent on each device, and the IP address is the one can be changed. Okay, and also the logical link control, or the LLC sublayer, handles framing, addressing, and flow control. The speed depends on the link between nodes. Okay, for example, internet or Wi-Fi. Another thing, okay, the data unit on layer 2 is a frame. What do you mean by that? Each frame contains a frame header, body, and a frame trailer. So header typically includes MAC address, as we already know it, for the source and destination nodes. Body consists of bits being transmitted, or in other words, in short, the message containing inside. So here are the visual representation of the layer 2, or the data link layer. Okay, so we have from network layer, before it passed down to physical layer, or the hardware for short, or one of the best example, or the easiest example, the hardware, computer, or computer device. Here you go. Okay, from network layer, data link layer, it will scan in the data link layer, then go to physical layer. And when you go to the receiver, it repeats the same process. So data link layer allows nodes to communicate. In short, data link layer allows nodes to communicate with each other within a local area network. The foundation line, discipline, flow control, and error control are established in this layer. Okay? So layer 3, the network layer. This is where we send information between and across networks through the use of routers. Instead of just node-to-node communication, we can now do network-to-network communication. Okay? So routers are the workhorse of layer 3. We couldn't have layer 3 without them. So they move data packets across multiple networks. So not only do they connect to internet service provider or the ISPs to provide access to the internet, they also keep track of what's on its network. Remember that switches keep track of all MAC address on the network. What other networks it's connected to, and the different path for routing data packets across this network. Okay, so for example, when you will see this when you configure your Wi-Fi or the internet connection at home, at work, or anywhere, as long as there is connection. So routers store all of this addressing and routing information in routing tables. Therefore, here's an example of routing table. Yes, this is the example of routing table. So network layer allows nodes to connect to the internet and send information across different networks. So moving on to layer 3. So what is layer 3 or the network layer? Typically, each data packet contains a frame plus an IP address information wrapper. In other words, frames are encapsulated by layer 3 address information. So the data being transmitted in a packet is also sometimes called a payload. While each packet has everything it needs to get to its destination, whether or not it makes it there or another story. Okay? So in the network layer, they don't do anything but send the traffic where it's supposed to go. More data on transport protocol on layer 4 or the next layer. So meaning to say, layer 3 or the network layer transmissions are connectionless or best efforts. Okay? So once a node is connected to the internet, it is assigned the internet protocol IP address, okay, which look like either this one, the version 4 IP address, or the version 6 IP addresses. Okay, and IP addresses are associated with physical nodes MAC address. So IP address and MAC address are always together whenever you are connected to the internet. Okay, so moving on to layer 4 or the transport layer. This is where we dive into the nitty-gritty specifics of the connection between two nodes and how information is transmitted between them. It builds on the function of layer 2, the discipline, flow control, and error control. Okay, this layer is also responsible for data segmentation, or how data packets are broken up in sent over the network. So transmission control protocol and user datagram protocol, UDP, are two of the most well-known protocol in layer 4. As we said earlier, TCP or transmission control protocol is very useful in terms of exchanging information over the network. So the TCP, a connection-oriented protocol, prioritize data quality over speed. Okay, they don't care about speed, it's fast or slow. All they care about is the quality of the data. All right. So TCP or transmission control protocol can be found in layer 4. Also ensures that packets are delivered or reassembled in the correct order. Okay. And UDP is a connectionless protocol, prioritize speed over data quality. UDP does not require a handshake, which is why it's called connectionless. Okay, that's why. So because if information is split up into multiple datagrams, unless those datagrams contains a sequence number, UDP does not ensure that packets are reassembled in the correct order. Okay, so move on to layer 5, or the session layer. This layer establishes, maintains, and terminates session. A session, so what is a session? It is a mutually agreed upon connection that is established between two network applications, not two nodes. No, okay, not two nodes, but the two mutually agreed upon connection. So layer 5 does not need to retain the concept of a node because that's been abstracted, okay, or been taken to the previous layer. So a session is a connection that is established between two specific end-user applications. So there are two important concepts to consider here before we move on to layer 6. So client and server model. The application requesting the information is called the client, and the application that has the request information is called the server. The request and response model, while a session is being established, and during a session there is a constant back and forth of request for information and response containing the information. Or hey, I don't have what you're requesting. That's how it works in the session model. I mean in the session layer. Okay, so what else? Session may be opened up for a very short amount of time or a long amount of time. They may fail sometimes too. It depends on the on the circumstances. So the session layer initiates, maintains, and terminates connection between two end users application. It responds to requests from the presentation layer and issue requests to the transport layer. So in other words, in short, to be easy understood, a session layer acts like the gatekeeper between the nodes. So we're almost there. Layer 6, the presentation layer. This layer is responsible for data formatting, such as character encoding and conversion and data encryption. So in layer 6, I'm sorry about that. So what do you mean by that? So in the operating system that hosts the end user application is typically involved in layer 6 process. This functionality is not always implemented in network protocol. We'll see about that. So layer 6 makes sure that the end user application operating on layer 7 can successfully consume data and of course eventually display it. So in other words, layer 6 is very close to the end user. That is just like you and me. What else? There are 3 data formatting methods to be aware of. Okay? So the American Standard Code for Information Interchange, or ASCII, this 7-bit encoding technique is the most widely used standard for character encoding. Okay? Which provide most of the character necessary for languages spoken in Western Europe. The second is the extended binary coded decimal interchange code designed by the IBM for mainframe usage. This encoding is compatible with other character encoding methods. And the last will be the Unicode. That is, character encoding can be done in 32 to 16 or 8-bit characters and attempt to accommodate every known written alphabet. Okay. Also, layer 6 is responsible for the encryption. Okay. So the presentation layer, or layer 6, formats and encrypts data before it reaches to the end user or be passed down from end user to the layer 5. And the last layer is the application layer. So this layer that is ultimately responsible for supporting services used by end user application. The application includes software programs that are installed on the operating system, like internet browser, for example Firefox, or word processing program, for example Microsoft Word. or the application layer, in short, is the application where users use to interact with the computer or to connect with other users out there. For example, Facebook, Twitter, Instagram, and so on. So applications can perform specialized network function under the hood and require specialized service that fall under umbrella of layer 7. So electronic mail or Gmail, for example, are specifically created to run over a network and utilize networking functionality such as email protocols, which fall under layer 7. So what's more? So applications will also control end user interactions such as security checks, for example, MFA, identification of two participants, initiation of an exchange of information, and so on. So protocols that operate on this level include File Transfer Protocol, FTP, Secure Shell, SSH, Simple Mail Transfer Protocol, SMTP, Internet Message, and also, of course, Hypertext Transfer Protocol, which used to link the web browser and your browser. Okay, so here are the visualization of the application layer. So far we have studied from the physical layer, that is the hardware of where information ends, to the other side of the user or the next destination. Okay, from physical, we know that physical to data link, network, transport, session, presentation, and lastly, just now we have explained and studied about the network layer, that is layer number 7. So the application layer owns the service and functions that end user applications need to work. It does not include the applications themselves. So it's just the like the rules, okay, the rules that govern such an application. So that is the end of our presentation concerning the TCP/IP and the OSI model. Thank you for watching.